All right, welcome to the probability introduction lesson. I'm going to pre-apologize for me stumbling over my words during this lesson because I really trouble, you're right there, right? I really struggle, not trouble, I really struggle with getting like the English explanation out, even though English is my only language. I still struggle with like how to explain the numerator of these problems. So let's just consider this a pre-apology. All right, so keywords that we need to know before we get started here. So first off, what a sample space is, and that's the set of all possible outcomes. That's going to be our denominator, right? And then we have the event, which is a subset of a sample space. That's our numerator. Because when we're finding probability, which is when we were doing permutations and combinations, I accidentally kept saying, what's the probability of, and we weren't doing probability yet. Like we were just talking about like all possible outcomes. Okay, or how many ways can this happen? We weren't talking about the probability of that happening, which is what this lesson is. So first off, we're going to find the sample space for each of the following. So when tossing a coin, what are the possible outcomes, right? So when you're tossing one coin, you can get a heads or you can get a tails. So there are two possible outcomes. I need this paste image thing to go away, but it's not going to happen. All right, so when you're tossing two coins, what can happen? Okay, so you can get a heads, then a tails. Or I should start with heads. Let's start with that. You can get a heads and a heads. You can get a heads, then a tails. You can get a tails, then a heads. Or you can get a tails and a tails, right? So I want to realize is that these are two separate coins. So heads on one and tails on the other is different from tails on the first one and heads on the second one. So there are four outcomes for tossing two coins. Three coins, you can get heads, 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 tail, heads, heads, tails, tails, or heads, heads, tails. That's all starting with heads first. That's why I said or. Now, if you, for the first one's tails, you can do tails, 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 heads, tails, tails, heads, heads, or tails, tails, heads. So there are 8 different outcomes there. Okay, and those are your sample spaces. All right. So now we're going to talk about the probability of an event occurring. So the probability of an event occurring is found by dividing an event, that's what I explained in the first part, by the sample space is what we just did, okay? Essentially, it's how many ways to achieve a certain outcome divided by all possible outcomes. All right, so let's talk about two coins being tossed, which we already did. We're not going to use our written out sample spaces. We're going to see how to do this without written out sample spaces. So two coins are tossed. What's the probability that both land heads up? So we want to do the probability of heads, heads. Okay. So if I'm going to toss my first coin. What's the probability of tossing a heads, right? So there's 1 out of 2, right? You either have heads or tails for the first one. So there's your 2 outcomes. And then you want to get heads for the numerator, right? That's your event that you want. And same thing for the second one, right? So the probability of getting heads, heads is 1 out of 4 or 25%. And the same question, I don't like that there's 2 questions, but whatever. What is the probability that one coin is a heads and the other one is tails? So that is heads, tails, or tails, heads, because one of one, one of the other. So for my first coin being a heads and my second coin being a tails, or my first coin being a tails and my second coin being a head. 1/2 times 1/2 is a quarter, plus another quarter is 2 quarters or a half, which is 50%. Okay, so that's the probability. And now if we look back at just our sample spaces here, if it says what's the probability of getting a heads, heads, if you look, this is our 2 coin toss right here, right? Getting a heads, heads, that's 1 out of 4. Getting a heads, tails, or a tails, heads, 2 out of 4, half, right? Okay, but this is the math that it comes from. Okay, what is the probability of getting a flush in poker? So in my last screencast, I talk about all different ways to get a flush and all different ways to get a poker hand, right? So this is now the probability. Kind of talked about this a little bit, and I'll actually go back to those notes just so we can see it. So probability, why is it in purple? OCD. Probability of getting a flush. So I like doing the denominator first, which is all possible outcomes. So of the 52 cards, we are choosing 5 cards. And then now we want to know in the numerator, is that event occurring? So how many different ways can we get a flush? So to get a flush, you first have to have all of the same suit. So there are 4 suits in a poker hand. So not in a poker hand, there's 4 suits in a deck of cards. So from the 4 suits, we are going to have to choose one. And 4 choose 1 is just 4. So it's just going to take whatever we get and multiply it by 4 for each different suit. Can I think of that word for a second? All right, so now from that suit, there's 13 cards in each suit, and I want to choose 5 of those cards. All right, because I want all 5 to be from that same suit. So now I can go ahead and get what each one of these is. Now, instead of putting this in my calculator, my calculator is right off to the side here, but instead of putting this in calculator, I'm actually going to go back to my old notes right here because we already did that. There it is, right? Nope. There, nope. There she is. Okay. So 52 choose 5 was 2,598,960. And then 15 choose 5 times 4 choose 1 was 5,148. So you could put in your calculator again, 5,148. 5,148. So my numerator is 5,148, which I could get by putting in my calculator. You should do it. And then my denominator is 2,598,000. Oh, I forgot already. I don't want to type it wrong. I don't want to do it wrong. This is back and forth and back and forth. 598,960. 960. All right, and now what we can do is we can put that in our calculator. I'm going to do that in my calculator now so I can quit. 5148 divided by 2,598,960. I'm going to get a decimal in my calculator, which is 0.00198. And then, like, if I said that's the probability, that doesn't, like, resonate well with people. So let's actually turn it into a percentage by moving the decimal over 2 places. So we're going to say that it's 0.198%. So even though there's over 5,000 different ways to get a flush, the probability of getting a flush in a 5-card poker hand is less than 1%. It's 0.198%. Okay, what's the probability of getting a full house? So hopefully I over-explained that last one, so this one doesn't seem as bad. All right, probability of getting a full house. So once again, I'm getting 5 cards from that deck of 52. Okay, so if you don't know what a full house is you're getting 2 of one type. So like 2 aces or 2 queens or 2 jacks or 2 sevens, okay? So there are 13 different cards you can have. Ace, jack, queen, king, 10, 9, 8, 7, 6, 5, 4, 3, 2. All right, so there's 13 and you're going to choose one of them, all right? And then from those, you want 4 of the same kind of those 2 cards, okay? And so now you have to choose another. So like, let's say those were aces. Now you have to choose something else. There's only 12 left and you're choosing one of those. And you want those 4 cards, those to be 3 of a kind. So of the 4 that you have, you want to choose 3. All right, we're going to put that in our calculators. 13 choose 1 times 14 choose 2. Let's actually make sure we remember how to put that in our calculator. And I'll just do it once because it takes, we know what it takes. It takes a lot of button pushing here. Okay, so I'm only going to show you once because you can always pause the video and try them yourself. So I want 13, choose 1, which is just 13, but I'll do it anyways. So 13, go over to probability. Option number 3 is combinations, choose 1. And then I want to do times 4, choose 2, which is 4. No, it's not. So good thing I didn't do that for math, probability. Option number 3, choose 2. Oh, and I chose multiplication because it's and, it's not or. And I want to do 12, choose 1, which is 12. Times 4, choose 3, which is 4. 4, math. See why I'm going to have you do these on your own. Oops. Choose 3. This is going to be my numerator. 3, 7, 4, 4 over, and then my denominator, 2, 5, 9, 8, 9, 6, 0. So now I'm going to type that. So I'm going to do second answer divided by 2, 5, 9, 8, 9, 6, 0. Enter. And we have 0.00144. Turning that into a percentage, move the decimal over 2 places, we have 0.144%. So you could also see that full houses are harder to get than flushes are. All right. Okay. All right, I'm going to get my calculator out of the way, and I'm just going to use my calculator in my hand if I need it. Otherwise, I also did an answer key before I started the lesson, so I can just write down the answer. You should be typing in your calculator to make sure you're getting these answers, though. All right, so this says, in a state lottery, a player chooses 6 different numbers, 1 through 40. If these 6 numbers match the 6 winning numbers drawn by the lottery commission in any order, so we know you're using combinations, the player wins the top prize. What is the probability of winning the top prize? So probability of winning the lottery. And this is this specific lottery. Like Mega Millions and Powerball, they're even way harder than this. All right, so we need how many different combinations there are of the 6 lottery numbers that are chosen. So there's 40 options, and we're choosing 6. Those are all possible outcomes, right? So now we have to talk about how many different ways can you win, can your 6 numbers be chosen? Well, there's 6 numbers, and you have to get those 6 chosen. So really, 6 choose 6 is 1, right? So we have 1 over, actually, I'm going to type this one in my calculator again. I know I lied because I want to see what happens, because the odds of this are slim, right? So 40 math probability. Nope. Try that again. 40 math probability. Option number 3. 6. Enter. So that is 3,838,380 different outcomes. And we have to get the one that we chose. So 1 divided by second answer. Okay, and I knew it was going to look like this. Good. All right, so that means that this is scientific notation. It's times 10 to the negative 7th. So we have to move the decimal 7 places to the left. Okay, so if we move the decimal 7 places to the left, that's adding 6 zeros in front of it. So 1, 2, 3, 4, 5, 6 zeros, and then 2, 6, 1. All right, now we can turn this into a percentage by moving the decimal over 2 places. And we have 0.40, 1, 2, 3, 4, 261%. So that is the probability of winning this lottery. The probability of winning Powerball or Mega Millions is actually even smaller than that. Okay, now I'm actually going to get rid of that and hopefully not have to bring it up again. Okay, so it says a bag contains 6 red, 6 green, 6 blue marbles, each color containing the numbers 1 through 6. So there's like a red 1, red 2, red 3, red 4, red 5, red 6, green 1, green 2, so on and so forth. When drawing 3 marbles, what's the probability of getting all reds? So we want the probability of getting all red marbles. Okay, so for my denominator, I'm talking about all possible outcomes. So there's 18 marbles and I am choosing 3. So that's going to be all possible outcomes. So now also you have to remember is that we're using combinations here because the order does not matter. So you might be saying like, isn't there a way where I can do 6 over 18 times? And I like what you're thinking there, but that is permutations. That's when the order does matter. That's when you picked that one out. And that is specifically that ball and so that's when the order does matter, I should say. That's when the order does matter. And that's when it's like that specific ball, like red 6. Okay. All right. I know my brain paused there, but I said that was going to happen during this. Okay. So let's talk about the numerator. What's the probability of getting all reds? So we have to talk about the numerator, which is not the probability of getting all reds, but all ways to get just reds. Okay. So we have to talk about just reds. How many just reds are there? 6. And we are choosing 3. Okay, so we're going to put that in our calculator. Go ahead and pause the video and try putting that in your calculator. 6 choose 3 is 20. 18 choose 3 is 816. So you can just put the whole thing in your calculator like 6C3 divided by 18C3 and just put the answer. Or you can do 6C3 and get that it's 20, 18C3, get that it's 216, and then divide them. So I will put these in my calculator. 20 divided by 816 is 0.0245. 1. So put that at, that's the decimal I'm getting because I get 0.98 after that 5. Move the decimal over 2 places, and that's 2.451%. Okay. All right, when drawing 4 marbles, what's the probability of getting at least 3 blues? So probability of getting at least 3 blues is, when you're drawing 4 marbles, is 3 or 4 blue marbles. Okay, so possible outcomes. There's 18 marbles, and we are drawing 4 of them. And then we want the probability of getting 3 or 4 blues. So let's first talk about the 3 blues. So I want to know how many different ways I can get 3 blues. So from the 6 blues, I am choosing 3 of them. But now I also need 1 more marble. And it's not going to be blue. So how many marbles are not blue? 12. Or, that's the or. So now we're going to talk about just getting 4 blues. So from the 6, we're getting 4 blues. Now I'm going to put that in my calculator. All right, so I got 6, math, probability. Actually, I'm going to pause the video and type this, and I'll tell you what I get from the numerator to make this video shorter. You should do that too. Okay, I did it. So the numerator is 255, if you want to check that. And then the denominator is 18 choose 4, not 18 choose 3 like the last one, which is 3060. Put that in your calculator, you get 0.08333. Move the decimal over 2 places to the right, and I have 8.333%. Whoa, that was a weird way to make percent, huh? Okay. That video was paused for a long time because I kept typing 18 choose 3 in my calculator like the last one. Gotta pay attention. All right, when drawing 3 marbles, we're back to 18 choose 3 for the denominator. What is the probability of getting 1 of each color? So probability of getting 1 red, 1 blue, and 1 green. So one way that people accidentally do this wrong is that they'll do 6 over 18 times 6 over 18 or 6 over 18 or 1 out of 3 times 1 out of 3. And they'll say, oh, it's 1/9. No, 1/27. And the reason that doesn't work is because that's saying that like you had to get the red one first. You had to get the blue one second. You had to get the green one third. So it doesn't work that way. So the way that I'm showing you is the way that it does work. Okay. All right, so you're choosing 3. So out of the 18, you're choosing 3. And then 1 red, the probability, not probability, I did it again. How many ways can you get 1 red? So from the 6 red marbles, you're choosing 1. And from the blue marbles, you're choosing 1. And from the green marbles, you're choosing 1. So that's 6 times 6 times 6, which is 216 over your 816. So 216 divided by 816 is 0.26471, which is 26.471%. Okay. When drawing 5 marbles, what is the probability of getting all prime numbers? So probability of getting all prime numbers and it's like, what? We're talking about colors, right? But they also, if you don't remember, it says that each marble, red marble, had a 1, 2, 3, 4, 5, or 6 on it. All right, so you're choosing 5 marbles. So that's 18. Choose 5 for your denominator. And then from your numerator, you want to get all prime numbers from the 5 numbers that you're choosing. So we want to get all 5 numbers to be prime. So we need to know how many prime numbers are in the bag, right? So on each of the balls, there's 1, 2, 3, 4, 5, 6. So out of that, 2 is a prime number, 3 is a prime number, 4 is not, 5 is not, or 5 is, my bad, 6 is not. So there's 3 prime numbers on each color, and then there's red, blue, green. So this is a total of 3 times 3. There's 9 prime numbers. Okay, that was some math, I'd say. So 9 probability, choose 5 is 126 over 18 math probability, choose 5 is 8568. Divide those, divided by second answer, I get 0.01471, which is 1.471%. Okay, goody goody. All right, when drawing 3 marbles, what's the probability of getting at most 3 blues? At most 3 blues. Okay. So at most 3 blues means that you could get 3 blues, all right? Or you can get 2 blues. So I should write the word or. So you can get 3 or 2 or 1 or 0 blues. Okay, so we are 18, choose 3 again. I always want to put a fraction bar there, which doesn't go there. And we already know that, so I'm not going to type that in my calculator. That is 816. All right, so the probability, I did it again. I told you I would, okay? So I want the ways you can get 3 blues. So I don't think my numerator is big enough here, so I'm going to move this over. Make this longer. Okay. All right, how many ways can you get all 3 blues? So there's 6 blues, and you can choose 3 blues, okay? Or let's talk about how many ways you can get 2 blues. From the 6, you can get 2 blues, but that means that from the other 12, you would get another color. All right, for 1 blue, obviously very similar to this, 6, choose 1. From the 12, you're getting 2 other colors. Move this over, still not long enough. Good. Or, how many ways can I get 0 blues? So from the 6 blues, I'm not getting any, okay, which I don't even need to put that down because that's 1. And then from the 12 other colors, I'm getting 3. All right, put that in my calculator. I already did it, not gonna lie. Okay, so 6 choose 3 is 20. Plus 6 choose 2 times 12 choose 1 is 180. Plus 6 choose 1 times 12 choose 2 is 396. Plus 6 choose 0, which is 1. times 12 choose 3, which is 220. If you add those up, you get 816 over 816, which is 100%. And now we say, duh. Why do we even, what? Why didn't we just think before we did this? When drawing 3 marbles, what's the probability of getting 3, 2, 1, or 0 blues? Oh, okay, that'll happen no matter what I do, right? No matter what, if I pick 3 marbles, I'm either going to get 3, 2, 1, or 0 blues. 100% chance. Duh. All right, let's talk about cards again. Okay, we're drawing 2 cards from a standard deck of playing cards. So my denominator, from the 52 cards, I'm choosing 2. What's the probability that at least one of them is an ace? So at least one of them is an ace is that 1 or 2 of them are aces. All right, so once again, my denominator is 52, choose 2, because I'm choosing 2 cards from the deck of 52. So let's just talk about how many ways can I get 1 ace, right? 1 ace. So that means it's 1 ace and 1, I'm thinking and rubbing my head right now. So I'm going to get, how many ways can I get 1 ace and not an ace? So there's 4 aces and I want 1 ace, or 48 cards and 48 not aces and I want one of those. Or, so now let's talk about choosing 2 aces. How many different ways can I get 2 aces? Well, there's only 4 aces and I want both of them to be aces. All right, time to put this in my calculator. Okay, let's talk about the numerator. So I'm going to pause the video and do it. I'm really proud of myself because I did the numerator in my head. Well, I knew 4 choose 1 is 4, 48 choose 1 is 48, so 4 times 48 plus, and then 4 choose 6, or sorry, 4 choose 2 I knew was 6. So that is 198. And then I definitely use my calculator for the denominator because no clue. 1326. Put that in your calculator, you get 0.14932. So that gives us 14.932%. Voila. Next one, what's the probability? Oh yeah, we're still in the same section, it's part B. What's the probability that one of them is the queen of hearts and then the other is another heart, right? So we want the probability of the queen of hearts and another heart. That's pretty, huh? Okay, so once again, 52 choose 2. And that is, let me look back up there, 1326. Okay, so ways I can get the queen of hearts. Well, there's 1 queen of hearts and I would have to choose it. And then ways that I can get a heart. Well, there's 13 hearts, but the queen of hearts is already out of the deck, right? So that's 12 hearts left and I want one of them. I can do that in my head. 1 times 12 is 12. Once again, so proud of myself. 12 divided by 1326 is 0.00905. So that is 0.905%. Okay. So once again, small percentage. All right. Next, we have 2 6-sided. I'm going to do these a little bit differently. You'll see why in a second. So 2 6-sided dice are tossed. What is the probability that the total of the 2 dice is 7? Okay. So probability that the sum, that says sum, sure, is equal to 7. All right. So when you toss 2 6-sided dice, there are 36 outcomes, right? Yeah, because there's 6 times 6, or 6 choose 1 times 6 choose 1. 6 choose 1, so 36. So I'm going to put 36 in the denominator, okay? And then what's the probability that the total of the 2 dice is 7? So I can think of the ways that the dice can be 7. Like I can say, okay, there's 1 and 6 and 6 and 1. That's 2. 2 and 5 and 5 and 2, that's 2 and 3 and 4 and 4 and 3, that's 2, so there's 6 total. Or I can make a chart of all the possible outcomes. I'm going to choose to make a chart of all the possible outcomes because I can already see that the next one is at least 5, and it's going to be helpful to have all the outcomes listed here. Okay. All right, so there is, I don't know why I made it like this, but I'm going to anyways. All right, so 1, 2, 3, 4, 5, 6 for my first die. 1, 2, 3, 4, 5, 6 for my second die. So the sum here is 2, 3, 4, 5, 6, 7. The sum here is 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. So fun. 5, 6, 7, 8, 9, 10. I could have just Googled a picture. 6, 7, 8, 9, 10, 11. But I missed out on the fun. 7, 8, 9, 10, 11, 12. Okay, that was fun. All right, so this one is, what is the probability that the total of the 2 dice is 7? 1, 2, 3, 4, 5, 6. 6 out of the 36, like I showed you, outcomes, which is 1/6, which you didn't have to simplify that, but I like to. And then when you put 1 divided by 6 in your calculator, you get 0.166666666, right? 0.1. I almost put it in my calculator, even I knew it. Oops, I need another one. 6, 7. Move the decimal over 2 places, and you have 16.667%. 6, 7. Okay, yeah, I just did that. What's the probability that the total of the 2 dice is at least 5? So this is 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12. Once again, we know that there's 36 outcomes. All right, so what's the probability that it's at least 5? So here is everything to the right of this diagonal line here. I could count up, or I can count the ones that are not, or the less than. So it's 1, 2, 3, 4, 5, 6. There's 6 that are not, so 36 minus 6 is 30 that are, which is 5 out of 6, which is equal to 0.83333. So 83.333%. Sorry if I mumbled through that one, but I feel like these are way easier than the hard hands. Okay. All right, so lastly, we have at a wedding, a DJ has a list of 10 songs left to play, but only has time to play 6 more. So sad. So there's my total. There's my sample set, or not my sample space, my bad. A guest has 4 songs in mind that he really wants to hear before leaving. What's the probability that the final playlist includes all of the guest's preferred songs? Okay, so the probability that this guy's all 4 songs are played. All 4 songs played. Okay, so all possible outcomes. There's 10 songs left to play, but there's only time for 6 more. So that's all possible outcomes. And then this guy, what are the ways that he could hear his songs? So he wants to hear all 4. So that's if he gets all 4, but then there's also 2 more played, right? And there's 6 left to play. Okay. So 4 choose 4 is 1. So I'm just going to do 6 math, choose 2 in my calculator. 3. I did 16. Can I fix it real quick? Delete. Okay. So that's 15 divided by 10 combinations of 6. 210. 15 divided by 210 is 0.0713. So that is 7.143% that he will hear all 4 of his songs. Okay, great. Hopefully that was the longest screencast you've ever watched. Have a great day.